Welcome back to the arcade. Today we're going to be doing something a little different, although it is arcade related in a way. In this box here I got a new piece of test equipment, but this is the kit version. You can buy it two ways. You can buy it fully assembled and ready to test, or you can buy it in the kit and put it together yourself. This, of course, is the Neoloch Inquisitor, the Inquisitor IC testing system. And what it does basically, it has a core unit, and it uses plug-in blades, and depending on which blade you plug into it is what type of IC chips it'll test. And it's mainly for testing SRAM and DRAM memory chips. And it also has a PIA riot blade. PIA is a chip that you find mostly in pinball machines, but it's in some video games too. So it's useful to both the arcade collector and the pinball enthusiast if you're working on any board type repairs. And even if you don't do in-depth board repairs, a lot of times a board will just have a bad memory chip or you know, whatever. And if you have a device like this, you can easily test those chips, and if the chip is the failure on the board, you can easily repair it yourself. So okay, let's go ahead and empty the box out here and see what we got. Of course, this I'm pretty sure is the wall wart power supply, which it is. So it runs on AC power, but we won't need that right away. We have to build it first. And here is the core board, the one that the blades plug into. And of course, the company who designed this, I believe they've sold all the designs and everything. They got out of the business, and now if you want one of these, you can order it through Pinball Classics in the United States. And over in the EU, Pinball Solutions was carrying it. I don't know if they still do. I believe they're over in Belgium. But you can go to their website and look it up and give them an email if you're over in the EU or anywhere across the pond. They can probably tell you whether or not they still plan to carry it or not. But over here in the US, like I say, you can get it from Pinball Solutions. And I guess right here it says lockwinlit.com, so I don't know if that's Pinball Solutions website or not. I haven't looked that up. But if you do a search for the Inquisitor Neoloch, you'll be able to find all these links in the description. So it's not hard to find, and you save a little money by putting the kit together. Although if you buy the kit and all the blades, it can get a little pricey, but for what it does, if you're into board repair, I believe it's well worth the cost. And of course, if you're handy at you know, soldering, then it's no big deal to put the kit together. So that's what we're going to do. We're going to put the kit together. This is the core kit, the main unit. And this one right here is the 4116 DRAM blade, which does more than 4116, but anything in that family of DRAMs, it has a pretty good substantial list. And this one right here is the blade for the SRAM, and this one has a whole lot of different chips that it'll do. And of course you got the PIA Riot Blade, which does those peripheral interface adapters. That's what PIA stands for. And I believe the Riot chip, I believe the Star Wars soundboard uses one of them, but you find them in pinball machines too. So, okay, well, this is what we're going to get. There's one more blade that I didn't get, and let's see. I'm not sure which one that is. Yeah, it's the 9060 DRAM blade, which the 9060 DRAM is found in Space Invaders, which I don't have any Space Invaders boards or games. So at this time I decided not to get it. Now I might go ahead and get it just to round out the collection. I don't know if they're still going to produce any more blades in the future. It would be nice if they did, but for right now, this just serves a purpose, and I think it'll be a good addition to my arcade tech tools. So first thing I'm going to do is I'll put the blades aside because we're not ready for them yet. I'm going to go ahead and do the core unit first. So I'm going to open it up and get out all the parts and go over the instructions. I'm pretty sure it has instructions in here. And I'm going to go through the parts and label them and sort them out and get them lined up to make it easier for the assembly. So I'm going to do that and I'll be right back. Okay, I'm back. That didn't take too long, but I guess the thing that took the most time was to sort out the resistors. It's got 18 1/8 of a watt resistors, which are kind of small, and sometimes the colors are a little easy to get mixed up, so I had to take my ohm meter and I double checked them to make sure that I was reading the colors right and everything. So anyway, got all the parts here labeled and lined up, so make it easier to put them on the board. I got the board here, and I downloaded the instructions offline, which is easy to follow, blow by blow, telling you how to put each component on the board and where to put it. So it's very simple and very easy set of instructions. So I don't anticipate any problems. I did go over the material list, which has a list of everything that comes in the kit, and the only thing that I'm short of that they didn't put in the kit was the 2 silicon heat transfer pads for the 78 12 volt regulator and the 7805 volt regulator. But you put it directly on the board with a screw and a nut, and it's not really much of any heat sink capabilities on the board here. So I think I could probably get by without them, but just in case, I don't use the thermal pads, but I do have mica insulators. So I'm going to go ahead and just stick the mica insulators in place of the silicon thermal pads. I'm not going to put any heatsink compound on them, because if it turns out to be a problem with heat and I feel like they're getting too hot, I'll go ahead and get me some thermal pads and put them in here. So there's no need in putting thermal paste on here and getting it all gunked up. So I don't think it gets that hot, but we will see. Time will tell. All right, so let's go ahead and start putting these together. And they do it logically, like I usually do a kit. Whenever I used to put a kit together, I used to like to start with the smaller components and the components that sit low to the board, In other words, components like resistors and capacitors, and then work your way up transistors, and then finally, if you got, you know, got some LEDs and some header pins and sockets and that kind of stuff, I like to put them on last, and I think that's how they pretty much got it outlined here. So a well thought out approach to putting a kit together. So all right, well, let's go ahead and get started then. And I'm going to try to zoom this in so that you can get a view of what I'm doing. And there are some videos already on YouTube that show putting this together, but from what I've seen, most of them are not complete, and they're fast forward, you know, sort of just skipping through them and not doing, you know, any step-by-step instructions. So I always like to do my videos, even though I know it makes them long, I like to do it from start to finish and show all the steps in between. So that's what I'm going to do to this video. Maybe it'll help somebody that doesn't have the building skills and they're afraid that maybe they can't put one of these together. And I like to be able to show that, yeah, you can do it. Anybody can do it. Just take your time. It's not a race, and you just do one component at a time and double check your work. And as long as you got pretty good soldering skills, you'll be okay. Okay, and the way to get good is to practice, but you don't want to practice on this. Practice on something that's not going to matter if you mess it up. And once you get good, then you can start on something like this. So, okay. We're going to start with step one, install 390 ohm resistors. And there are 4 of those in position R13, R14, R17, and R18. So, let's see. These were real simple because they all came together. So I just made a little note on the bottom, 390 ohm, and I put the numbers on them. So we'll be able to put them in kind of easily. I did check them too to make sure that they were what they're supposed to be. Checked them with the ohm meter. So all 4 of these are the same, 390 ohm. So I'm going to go ahead and just pull all of them off, lay them down here, and we'll start with R13. So you want to look at the board and find where R13 is. They list it on the board, and there's R13 right there. So what I like to do is to get a feel for a board, because all boards have different spacing, I like to lay the component on top of the board where it's going to go and make a note at where I need to make the bend in order to get the holes to line up fairly close. So then I just take and put a little bend in it. Don't know if this is going to focus. Yes, it did. It's the first PC board I ever seen that's purple. The original ones were red, but hey, I like purple. It's kind of sexy looking. All right. These are 1/8 of a watt resistors, and the circuit board is mighty small terminals. Get my wire clippers here, and again I'm gonna clip the wires as I go. And that looks good. All right. First resistor done. All right. R14. R14 is right beside it. Okay, R14. Almost need a smaller tip on my soldering iron here. These are a lot smaller than I anticipated. Okay. Now, R17 and 18. Let's find where they are. Here they are together. Right there. R17 and 18. So I think I'll go ahead and put both of these in. And when I put resistors on a board, I like to put them all in the same way if they're oriented the same. I mean, resistors, it doesn't matter, but I just think the aesthetics of the board, it makes it look better when you have two resistors side by side and the colors are both lined up in the same direction. like I say, has no bearing on how a resistor functions, but it just makes it look better, I think. And the camera's slow to focus. Don't want to focus. Okay, that's weird. Yeah, this is definitely a lot smaller than I'm used to. This is almost like surface mount soldering. Take a close look at it here and see what it looks like. Yeah, it looks okay. Sure wish I had a smaller tip on my soldering iron though. Let me take a look and see if I got one. Okay, well, I knew I had a smaller tip here somewhere, and if you can see the comparison there, it's more of a real fine tip, where this is more of a blunt tip. Not quite a chisel tip, but it's got two little flats on either side, and the one I just put on there is like a pencil tip. So we'll try that and see if that's better. Okay. Alright, so we got the first 4 resistors on there. So let's go to step 2. Solder 3 1K ohm brown, black, red resistors onto R1, R15, and R16. And start with R1 is right here, which is next to 2 of the buttons on the board. So let's see. Here's 2 of the buttons, and we're looking for R1. And here's R1 right there. Alright, so we're looking for R1. Where is R1? There's R1, 1K ohm. Okay. I don't know what I got to do to get this camera to focus better. Didn't used to be so stubborn. All right, let's see how this new pencil tip was going to do here. Oh yeah, that's much better. Much better. Okay, I can deal with that. All right, R15. Looking for R15 right here, which is also a 1K. All right, let's find R15 on the board here. R15 is close to J2. Where's J2? There's J2, where that hole is right there. R15, right there. 15 and 16, right next to each other. So let's put in 15. And R16, which is also a 1K. And I want to put it in the same direction. Come out on me. All right, that'll do. Okay. Step 2 is done. Step 3, solder the 3.3 k ohm orange-red resistor into R2. Okay, so we're looking for R2. R2, not R2D2, but R2. And here's R2, 3.3K. Now let's find where R2 is on the board here. R2 is close to the resist. Let's see. Revision. I'm looking at a different board though, so it might not be. Yeah, R2. R2 is right there. I ought to break out my fine roll of solder. I got a roll of solder that is probably half the diameter of this right here. Would probably be perfect for this. I think I bought it for doing surface mount work. Okay, that one's in. Now step 4. Install a 10K ohm resistor, brown, black, orange, into R3, R6, and R7. There's 3 of them. So we'll start with R3, a 10K ohm. Okay, and there's R3, 10K ohm. And let's find out where R3 is now. Alright, R3 is right there in the middle between R4 and R7. R6. Here's R6, 10K. R6. R6 is up here. Okay, R6 is done. Now let's do R7. R7, another 10K. Let's figure out where R7 goes. I think I remember. Yeah, it goes right above R3. Right there. Okay. That takes care of all three of those. And now we can go to step 5, which is solder the 15 k ohm brown, green, orange resistor into R4. R4. R4, 15 k ohms. Let's figure out where that is. Across from where switch 2, S2 goes. Here's S2. Okay, R4 is the last one to go right here. Okay, that was R4. Now we go to step 6. Just solder a 20k ohm red, black, orange resistor into R5. Okay, R5. There's R5, 20k ohm. Now we're going to find out where R5 is. R5 is next to switch number 4. Here's switch number 4. And there's R5 right there. Okay, that does it for step 6. Step 7, solder the 1 meg ohm brown, black, green resistor into R9. So R9. R9, 1 meg ohm. R9, 1 meg ohm. Okay. Let's find where R9 is. R9 goes up above R8, which is the variable resistor on the board right here. So R9 goes right up there on that top edge. Okay, that one's done. Huh. Now I wonder why they're jumping to the voltage regulator. We got some more resistors. Did I miss putting some in? Did I skip a page? Let's see which ones I got left. I got R12, R11, R10, and R19. Let me go over this and see. I'll be right back. I didn't think I left anything out. I'm wondering if it's a sheet missing on the instructions here. Let me see what's going on. Be right back. Okay, I'm back, and sure enough, the instructions leaves out installing the resistors R10, R11, R12, and R19. They're not in the instructions. They're in the parts list, but they're not illustrated as putting them in an instruction. But anyway, so right here on the top side of the board, we got R10 goes right there. There's R11, R19, and R12. So I'm going to go ahead and install those right now. Since we'll go ahead and get the resistors out of the way, I'll go ahead and start with R10. I already checked them with the parts list, and checked them with the ohm meter, so I know they're correct in value. So we'll put R10 in. All right, now I'll put R11 in. All right, next is R12. R12 is right here. And last but not least, R19, which is a 1K. That goes right in between those last two we just put in. Okay, that finishes all the resistors. Okay, now we'll get back on track with the instructions. Step 8, install the 7805 voltage regulator. Solder the 7805 5-volt regulator into U3. Before installing the screw and nut, place one of the silicon thermal pads under the 7805, then install the screw and nut as shown. And they put the screw in from the bottom of the board, and the nut goes on the top of the board. And they didn't give me the thermal pad, so I'm going to go ahead and just put one of my little mica insulators underneath it, which is a standard mica, which you normally use with heatsink compound. But like I say, I'm not going to put that on it. If it seems like it gets hot, then I'll get me some thermal pads and put under it. No big deal. Okay, U3 is the 5-volt regulator. So here is U3, which is the 7805. All right. So U3 goes right here. So when you put that, line the hole up, the holes on the board are just below where the leads narrow down. So that's where we're going to bend them down at. right about there. That's going to be perfect. All right. So I'm going to take my little mica insulator. That doesn't line up with the holes, but we don't need the holes. All right. Put the screw in. Put the insulator on. And that's a Phillips screw. Alright, that's pretty tight. Alright, now we can solder these on. And that's it for that one. Now, step number 9. Install the 7812 voltage regulator. Solder the 7812 12-volt regulator into U2. Before installing the screw and nut, place one of the silicone thermal pads under the 7812. Then install the screw and nut as shown. Okay, same deal. U2 7812. Gonna bend it in the same place. Check it to see if it lines up. Perfect eyeballing. Okay, again, I get the mica insulator here. Get the screw and the nut. Put the screw, insulator, line it up. Tighten it down. Looks good. And let's solder it. Okay, regulator's on. Step number 10, install the 3-pin header and jumper. Solder the 3-pin strip header into JP1 along with the jumper. Push the jumper into the appropriate position for the type of power supply you are using. Okay. A 3-pin strip header in JP1. There it is right there, 3-pin header. And there's JP1 right there, where those 3 holes are. Okay, I'm gonna solder the middle one. And I'm gonna check it to make sure it's straight. And it is not. So then all we got to do is heat it up and push it until it's flat, and now it's straight. So now we can go ahead and solder the other 2 pins. Okay, now I'm not sure where to put this jumper, because the jumper is for if you're using a regulated 12-volt power supply or an unregulated power supply. I'm using the wall wart, so is that regulated or unregulated? says AC adapter, input 100 to 240 volts AC, 50-60 hertz, 0.3 amps, output 12 volt at 1 amp. I would say that's regulated. It's a 12 volt at 1 amp power supply, wall wart. So I would think that that's regulated. So we're going to try putting it on the regulated. Maybe I'll read in the instructions before I actually fire it up and make sure that's right. All right, I'll think about that. Look like it ought to tell you which position to put it in if you're using the wall wart. Okay. So that could be a little extra thing they could put in the manual here. They need to add those missing resistors and specify, you know, which way that jumper should be. Okay. Step number 11, install power switch. Solder the switch into S6. That's simple enough. We have a power switch, and the power switch goes into S6 right here. And let's see. Which way does it go? Doesn't matter. Shouldn't matter because all the terminals line up there in line. It's got 3 terminals. So if we put it in this way right there, that should be correct. Alright, let's see. I'm going to solder the metal can first on this side, which just holds it in. And now I'm going to check and make sure it's in flat. And it is. Looks good. So I'm going to solder the other hole down. Put a little more on this one. Alright, now solder the 3 connections. I sure am glad I put this small tip on my soldering iron. So make a note of that. If you're going to put one of these kits together, make sure you have a small tip for your soldering iron. It will be very difficult and sloppy with that other tip. The other tip is great for cap kits and general work on arcade boards, but even IC sockets, but man, it's rough on these small components here. Okay. Now the on-off switch is in. Got it on in the off position now. Okay, one last thing done here. Now, step 12, install DC power jack and potentiometer. Solder the DC power jack into J1 and the 4.7K ohm potentiometer into R8. Okay. Here is the jack for the power supply. J1. And just your standard jack with 3 pins on it. And that goes on the board right there. Again, we're gonna solder one leg. And check to make sure it's mounted flush on the board, because if it's not, then you can just take and heat up that one joint and push on it while you're heating up that joint, and it'll straighten itself right up. But we got it good and flat there, so we can go ahead and solder the other 2 terminals. Okay, that's done. Now we need to solder R8, which is the 4.7K ohm pot. And that's this little booger right here. I was reading through the instructions, and I believe this is the trim pot for the LCD display. It's sort of like a contrast control where you can turn this pot to darken or lighten up the display, you know. So it's like a brightness or contrast control. Okay, well, this is pretty straightforward here. It goes right here, R8. It's got 3 holes where it goes in. It's got 3 terminals on it, so it only goes one way. So far, everything has been lining up like a glove, and that's good. Alright, I should have put this one in first, because now I'm going to have a hard time holding that in. Let's see. I don't know where my foam pads are, but I don't think it would fit in there either. Alright, I'm just going to take a little piece of this clear tape, since I have it handy here. That's not quite going to hold it. Alright. Sometimes you just have to get a little ingenuity there. Make a little holder for it to stand up on. Okay, again, I'm just going to solder one of these. And one ought to hold it in. And now we can check it to make sure it's flat. And it looks good. So we can go ahead and solder the other two terminals. Okay. That's done. Okay, let's see what's next. Step 13. Install the 0.33 microfarad capacitors. Solder the 0.33 microfarad into C1 and C3. And it is showing it C3 and C1 on either side of this regulator. Let's see which regulator that is. That's the 12-volt regulator. And C1 goes there, and C3 goes here. C1 and C3 are both the same value. This tape again. I remember that stuff from the cap kit and the monitor. Okay, that one's freed up. Again, it's got to be an easier way to get that stuff off. Okay. These are electrolytic capacitors. And the board is marked. The plus is on the top on both of them. And it's also got a square around the hole. So That means the square is positive. Alright, I'm going to have to do this the old-fashioned way. Actually, I think they'll hold themselves in because they're taller than the rest of it there. Let's try that. Yeah, they'll hold themselves in. Okay, both of the capacitors on. Let's see what's next. Now it says to power up core and test voltages. Now is a good time to power up the tester and check voltage to make sure everything is operating properly. Follows is a list of test points along with expected voltages. C4 should be unpopulated. C4. Okay, C4 is unpopulated. We hadn't put C4 in yet. Well, C4 should be unpopulated plus 5 volts. Does that mean we should be getting plus 5 volts across where C4 goes? And then U4, which is an IC right there, that's U4, which is an 8-pin, and we got to put a socket in there later, but pin 1 is the output. Pin 2, it says 1.252 volts fixed plus or minus 1.5%. Pin 3 input voltage divided 10 plus or minus 1.5 volts. Pin 4 is ground. Pin 5 input voltage divided 10 plus or minus 1.5. Pin 6 1.252 volts. Pin 7 0 and pin 8 plus 5. Okay, I'll test the power supply before I hook it up. I'm going to skip this section. I don't think I need to do that. Okay, in step 15, install push button switches. Solder the push button switches into S1 through S5. Okay. It has these little push button switches. And let's see. Do they have a certain way they need to go on? Okay, they don't fit that way, but they do fit that way. So they only go on one way. And they snap in, they hold themselves in place. That's neat. Okay, let me make sure they're all in and flat. They're all holding themselves in real tight. I'm still going to solder one leg on each one of them and then check them. Okay. They all look good. Let's go ahead and solder the rest of them. Okay, they all look good. All right, let's see what's next. Step 16, install red LEDs. Solder in the two red LEDs into LED 1 and LED 2. Note, the shorter pin is pin 1 and goes in the hole with the square pad. Okay, so The short pin goes in the hole with the square pad. All right. Here are the two red LEDs. And if you notice, one leg is shorter than the other. These go in right here, which is LED 1 and LED 2. Short leg goes in the square hole. If I can get it go in. There we go. Same with the other one. The short leg goes in the square hole, or the square pad. All right, let's see how that's going to do. Need something to hold that up just a little bit. Okay. Again, I'm just gonna solder one of each. I wanna look at them and make sure that they're lined up kind of straight. That one is a little off. All right, that looks good. Okay, that's done. Step number 17, install the 28-pin socket. Solder the 28-pin socket into U1. Okay, here's U1 right here. So that's a 28-pin narrow socket, huh? Yeah. Okay, here's the notch end. According to the board, the notch end goes up here. And this is one of those they bent so that they hold themselves in. That's nice. Still want to solder one on each side or on each end and check it before I go soldering all of them. Okay, socket looks good. Yeah, this fine tip on this is making this easy. All right, that looks good. That's done. Now, what do we got left? Eight-pin socket into U4. Soldered 8-pin socket into U4. Okay. There's U4, the notch is up top. This socket pins are bent. Okay. Should be able to get them in now. This is just a regular straight socket, so it's not going to hold itself in too good. Let's see. Again, you got to get creative to try to find a way to. Whoops, slid off. Dang it. Alright, let's see if I can get it started here on one pin. Alright, that ought to hold it. That looks good. All right, let's see what's next. Step number 19, getting up there. Install the 0.1 microfarad capacitor and the bicolor LED. Solder the bicolor LED 3 leads into LED 3. Note, the shortest lead is pin 1 and goes in the hole with the square pad. Okay, here's the LED, and this LED has 3 colors to it. It has orange, red, and green. The orange is when it's testing. The red means it didn't pass the test, and the green means it did. So alright, it goes right here in the LED 3 slot. The short leg goes in the square hole. Okay, that's going to be a wobbly little sucker. Okay, I think I can do it like that. Yeah, that looks good. All right. Now this one, I don't know whether I should cut it off. I'm probably going to have somebody print me a 3D case for this, and I don't know if this mounted flush is going to be flush with the top of the case. I think I'll just leave it a little bit longer. I'll just clip it off and let it hang down a little bit, so if I need to I can move it up a little bit, just until I find out I get the case, and that'll give me a little wiggle room if I have to extend it to make it come out of the case. I'll just have to be careful with this in the time being to make sure I don't bend these over by setting it down flat on the table. Okay. Now, we also have to put in the 0.1 microfarad capacitor at C4. So this is it right here. C4 0.1 microfarad. And C4 goes right there. Okay. Okay, that's done. Let's see what's next. Step number 20, install card edge connector. Solder in the edge card socket into J2. Okay. That's it right there. That's what the blade plugs into. And this is J2. Goes in this right here. Now, it does have numbers. This is a 50 pin edge connector. 1 and 2, 49 and 50. But they're not marked on the board, but it does have a a big arrow right here, which is number 1. Usually when it has that arrow, that means that's number 1. So this is number 1, so it should go in this direction, but I don't think it really matters. It doesn't look like it really matters. It looks like it would go either way because it looks symmetrical on both ends, but I'm gonna still put number 1 where number 1 is. So okay, that's not gonna do that. Let's see, that's a little bit too tall. And that'll work. Okay. Again, I'm gonna just solder one on each end, opposite of each other. Now take a look at it. It is sitting flat. So now we can go to town soldering 50 pins. Okay, one side down. Okay. Edge connector is done. Okay, step number 17. Next up is the LCD screen. I've found the best way to install these is to first put the straight pin head into a breadboard and then place the LCD screen over the pins. Okay, I have a breadboard. Don't know where it is. It's here somewhere, but I'm not going to look for it. Hey, it's just pins, right? All right, let's see. There's 2 rows of pins on this thing, so which one is it? Okay. This is this end right here. You got a row of pins here and a row of pins here. This is the one that the header solders into. So it would be this row right here. Now, the header pins, you got short legs and long legs. Which one does the short legs go in? Which one does the long legs go in? Well, let's see. We put the long legs in there. They stick up a right good little ways. We put the short end in. They stick up above. But then, how far down does this stick through? I stick down a right good ways on the bottom. So which way should it be? Doesn't matter. Well, one thing about it, when you put it down flat on here, the pins are tight in there. So you could get it started that way. Huh. Well, if I put the tall pins on the top side, it may interfere with the 3D printed case, because the newer version of the 3D printed case, the LCD screen comes right up to the top lip, and it would need that room for that. If I put the tall pins up here, I think it would hit it. On the bottom, it doesn't matter if they stick through. If they're too long, I can just clip them off. So I think that's what I'm going to do. Okay. So I'm going to put this on here like this. I'll put that on there to hold it down. That should do it. Let me get the pin started on both ends here. Okay, let's see how that did. Looking good. All right. Take that off and go ahead and solder this. Okay. Got a little solder bridge between two of them here. There we go. All right, looking good now. Okay. Now I got that soldered. Then carefully solder each pin. Okay, I did that. Now the LCD screen can be removed from the breadboard and soldered into the core module. Okay. So now we can put it in here. Alright, now I gotta find something to hold this side up. Like if I just put some weight on it. No, that ain't gonna do it. No, that ain't gonna do it either. Just got to get a little creative sometimes. Okay. Check and make sure. Yep, that's all the way down. That's all the way down. All right. Okay. Take a close look at those. Make sure we have no solder bridges and make sure they're all, yeah, they look good. Okay. Starting to look like something now. Okay. Step number 22. Install the 23017 and the LM258 PICs. Insert the MCP 23017 into the socket. Make sure the dimple is pointed towards the 1K ohm resistor. Okay. This big one right here. And there's the little notch. And the notch goes up on the top side right there. Okay, that's in. And now the LM258P. They've been over too far. Okay. Same deal. Notches up near the top. Okay, the ICs are in. Now, test 23. Test core module. Insert a blade into the core module and power the tester up. You should see the Neoloch welcome message followed by blade-specific test information. Okay, well I can't do that yet because I haven't put a blade together yet. If the LCD screen is blank, then the contrast needs to be adjusted. Using a small screwdriver, slowly rotate the potentiometer counterclockwise until text appears on the LCD screen. If you turn the potentiometer all the way and nothing is showing up on the screen, then something is wrong. Power down the tester and double check all your solder joints. If the tester still isn't working, then proceed to the troubleshooting section. After that, we install the ZIF socket. Alright, well it looks like we're going to have to put one of the blades together. So let me stop it right here, and the blades are going to be a separate video, so I'm going to start filming the blade videos, and when I get the first blade done, then I'll come back and I'll finish this video. So, okay, but this video will be released before I release any of the blade videos, if that makes sense. Okay, so I will be back. Well, I made it back from the future so that we can continue with testing the Inquisitor Core, since I've had gone as far as I could putting it together, because we need a blade to plug into it to test it, and so I had to go back into the future, build the blade. Now I'm back, and here it is, the first blade I built. Now, you'll have to go into the future to see this video, because this will be video number 2. But we need it for testing, so that's why I had to go into the future and then come back, and now we can test the core unit. So, let me go ahead and plug in the blade. Now this is the SRAM Blade, which checks SRAMs, and the ones I'm going to be testing are the 2114s, because I just happen to have these are new ones supposedly, and then I have a box of assorted, could be bad, could be good, so we'll be able to test them and see how we're doing. Okay, I need the power supply. Of course, we can't test any yet because we still have to finish the core board here. We still haven't put the ZIF socket on, but we're up to the point to where this is what we have to do right now. So I'll plug power in. Okay. We should be ready to turn it on and see what happens. A little hard to see there, but it says select test 2016-2018. But the power LED is not on. So I wonder what the deal is there. All right, well, the contrast looks okay. Select test 2068, 2101, 5101. (2112, 9112, 2114, 6514, 9114, 2125, 2115, 6508, 2147. And I don't know if we're going back through it. This blade tests quite a few SRAMs. I believe we're just going back through the list again. Or that might be where it started. I'm not sure. But anyway, you just go through and pick the one that you want to test. And operations, LED normal, SRAM PC board V2 revision B. LED normal. LED reversed. Okay, so far the only problem I see is the power LED on the blade's not coming on, so I don't know what's up with that. I'm pretty sure I installed it the way it said to install it, but I guess it could be backwards. I'll have to test it and see if I get any power on it. All right, let me check that out real quick and I'll be right back. Okay, well, I checked it out and I'm getting 5 volts across the LED, so I don't know why it's not coming on unless it is in backwards. But I'll have to look at that. But that's something for the next video. I'll address that in the next video. I'll have to look at my footage when I was putting it together and make sure I put it in the way according to the directions. But I'm pretty sure I did. But I don't know, maybe something went awry there. Who knows? Okay, well, the main thing is it seems to check out and everything seems to be working. So now let's see. Go to the next section here. Step 24, install the ZIF socket. Solder in the ZIF socket. Okay. So here is the ZIF socket, which is, what does ZIF stand for? Zero insertion force. Basically, it just means you stick the chip in and then you pull this lever down and it pulls it tight against the leg. So you're not putting any force on the legs. You're not pushing it in a socket. You're just clamping down on the pins. So, okay. Let's go ahead and put this in. How many pins is this socket? I don't know. A lot. If I can get them lined up here. That's going to be a trick if the legs, any of the legs are bent slightly. Went in easier than I thought it would. Look at this through my magnifier, make sure all the legs are popped through so I don't get one that's bent over. Because you don't want to get solder this thing in and then discover that you got one pin that's bent over. That would really suck, wouldn't it? Then you'd have to unsolder all those pins. Let's see, how many pins is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 40 pin. Okay. Well, that's not all that bad. Alright, let's see. I think I got my foam blocks around here somewhere. I found them. Let's see. That'll hold it up off of there. Get the best angle here for soldering these things. Best angle so you can see and so I can see. All right, I think that'll do. No, actually, the pins are flat pins and they run this way instead of this way like a normal socket would. So I want to get the tip on the side of the blade or the side of the pin to get more heat in there. All right, half of it's done. Okay. Take a look at the solder job here. Looks good. All right. ZIF socket is in. Well, now that we got the ZIF socket in and we got all the soldering done to the board, so one thing that we shouldn't forget is to clean the flux off of the back of the board. Now, I guess it depends on what type of solder you're using. I've been using this, what's left over from this old Radio Shack 6040 rosin core solder, which has been a good roll of solder, but it's getting mighty thin, so I'm gonna have to get me some new solder before long. So I know they have different types of solder. They got the lead free, which I've never tried, but I've heard people say they don't like it. I'd rather stick with the 6040 lead 10 based rosin core. I know they have I guess it's a synthetic rosin now, and then they got the what do they call it, the no clean, which you're not supposed to have to clean. So I guess it depends on the type of solder you got, but since we got old school solder, we're gonna go old school and clean it. So we put down a paper towel here, and we're gonna just use regular rubbing alcohol. I got my scrub brush, and it's not very much, but still we need to clean it. So wet it down. And give it a good scrubbing. Get in between all these solder joints. First, we're just trying to loosen it up. Wetting it down. And hopefully it'll flow off the bottom of the board onto the paper towel. That's looking pretty good. Let's take another paper towel and blot it. And that's probably going to be good enough. And I'll just set it aside and let it dry. Not in any hurry. Yeah, looks like we got a little bit off. Okay. Okay, board's all cleaned up for the most part. I think it's good enough. Might not be perfect, but see if I can get a little close up. Ought to be good enough for government work. What can I say? Now, if so desired, add the rubber bumpers to your tester. Okay. It comes with these rubber bumpers. And I guess they're like little rubber feet. You put them through here, and I guess it just holds the board up off of the surface if you want to put it down. I suppose I could put these on. Supposedly it's a CLOV member. I'm not going to mention who it is in this video right now because not 100% sure when he's going to be able to do it, but he's offered to print a 3D case for this. Somebody on one of the 3D printer sites has designed a case for this, and then somebody else redesigned the case based off of the first person's case, made some changes to it. Supposedly it fits a little better now, and supposedly not too long from now, because he's going to be getting one of these himself, so he's going to have to print one for himself, so I think he's going to print me out one too. So we just have to wait and see how that goes, and when I do, if he does print it out and I get one, then I'll probably make a video on that too, so, and install this in it. But for the time being, I guess we can go ahead and put the feet on it, because we can always take them out. So all we got to do is just let's see. Well, that's strange. there are big holes here and little holes here. I think on the original one they were little holes. So I don't know if they'll fit on there or not. They'll fit in these little ones here. But I don't know if they'll fit on the big ones. Let's see. No, they just kind of flop around in there. All right, so I think I found another little design flaw here. Well, I guess they might fall out, but then again, I guess it ain't gonna hurt them to be in there. Okay. All right, now, should I put the blade in and test the chip? Okay, now that we got the ZIF socket in, let's go ahead and do some testing. Can take and put the SRAM blade in. And we need put the power supply back in. And let's turn it on. Okay, now the only thing I have to test right now is 2114, so I already got it set up on that. So, and I know I got one bad 2114, which came out of my Star Trek MPU board, or CPU board, which I have a video for that. We found out that it had one of these 2114s was bad and replaced it. So this, according to the board, was bad, and when I replaced it, the board started working. So let's go ahead and put this in, and we'll see what the tester says about it. You can see that. All right, all we have to do is hit the test button, and what should happen is the tri-state LED, which is three colors, orange, green, and red. When it's orange, it's performing the test. If it turns green after the test, that means it's good. If it turns red, that means it's bad. Of course, it'll also tell you on the screen here. So here we go. And bam, there it is, bad. The LED is red. So this one is indeed bad. All right, we'll take one out of my supposedly good stock, and we'll put this in, and let's test it and see what happens. It says okay, and the light is green, so it appears to be working. All right, let's just try one more. I got a box of unknown condition. Most of these are probably brand new, but every time I swap in a chip out of a board from a good known supply here, what usually happens is I get them mixed up and I forget, well, was that a good one or a bad one, and I don't want to have to go back to plugging them in and out of the board to find out if they're good or bad, so I just put them in a box. So now I got a tester that I can test them with. So it's going to randomly go in the box here and pull one out. And it is a 2114. So we'll stick this in the ZIF socket and let's test it. And that says it's good. So I can put that in with the good ones. Okay, well, it seems like we have success. The core unit is working. The blade seems to be working. But we're going to do a little more in-depth testing on the blade on the next video, which I had to go into the future to build the blade so I could test the core, if that makes sense. So now that we've tested it, I can go back into the future and finish the blade video. And what we'll do in that video is we'll sit down and test all these RAMs here and see if we find any more bad ones. So that's going to do it for this video. I hope you enjoyed the build. I hope you got a little insight as to what it takes to build a kit like this. And if you intend on fixing your own boards, or at least being able to test RAM, I highly recommend to get one of these Inquisitors and get the blades. You don't have to get all the blades. It's one blade I didn't get because I don't have a use for it right now. I guess I could in the future, so I might wind up getting the blade and just so I'll have it in case I ever need it, because you never know how long something like this is going to be around. It disappeared for a while. The original designer was building these and selling them, and I don't know the story behind what happened, but for a while there he stopped selling them. He closed down shop, and if it hadn't have been for the gentleman that took it over, then probably still wouldn't have them to this day. So if you have a need for it, or you think you're going to have a need for it, I suggest you look them up. And I guess their website is lockwinlit.com. Just do a search for Inquisitor, Neoloch Inquisitor, and you can find the links to it. I'll put a link in the description to the video too, so you'll be able to go straight to the site. If you're in the United States, you can buy it from the same place I bought this one from. I'm not sure about the EU site, which I believe is in Belgium. Last time I looked at their site, the picture they had up there said discontinued. So I don't know if that means they're not going to sell them anymore, or whether they're just out of stock and plan to get them back in. But if you live over on the other side of the pond, you can always drop them an email and see what's going on with it. See if they are going to be available again in the future, and if not, I don't know whether the source in the United States can ship overseas or not. It depends on, I guess, if they have an agreement. They might have an exclusive agreement for USA only, and the other company might have a agreement to sell them in Europe. So I don't know how all that works. So you just have to send them an email and find out what's going on. But highly recommend. It's going to be a great addition to the toolbox for test equipment, and it should help board repairs in the future. So I guess this has just been another arcade fix, or we're going to get ready to do some more fixing. So have you had your arcade fix today?